Hi class, let's take a look at example 2. In example 2, it's given as a function of y's. So we just have to be careful on this one. When you set up the integral, if you were to be given the actual coordinate points here, you have to make sure that you set it up in terms of the y's. So for this one, let me just, set, so I'm just going to say let g of y equal to the 2 so the 2 y to the 3 halves, then g prime of y is equal to, let me fix this y, so 2 times technically 3 halves y to the, and now it's going to be to the 1/2. And actually that was good news because the actual 2's cancel, so I'm just looking at 3y to the 1/2 for the derivative. Okay, so let me set up the integral. So in this case, L, or the arc length, so L is equal to, and we have to be careful, you're looking at it from the y's, so it's going to be from 0 to 1 of the square root of 1 plus g prime of y, I wrote x, g prime of y, and then squared, which actually, let me take it in this direction because I don't think it's going to be that messy, but we never know. So in this case, we're looking at the integral from 0 to 1 of the square root of 1 plus technically 3y to the 1/2, and then we're going to square dy, which is going to actually simplified to the integral from 0 to 1 of the square root of 1 plus actually 9y dy. So it turns out to be another simple u substitution. So let me let u equal to 1 plus 9y, so du is equal to 9 dy, or du over 9 is equal to dy. So our what appears to be a messy integral, it's actually not that bad. No, I think it's okay. So we're looking at the integral of the square root, and in this case this is going to be just a simple u, so u, and then technically the u over the values of 9 for the limits of integration. So for y is equal to 0, well, u is equal to 1, and for y is equal to 1, u is equal to 1 plus 9, we're getting 10. So this one's going to go from 1 to 10, 1 to 10, and then we have the 9 here. So let me simplify it. This is going to be a 1/9 integral from 1 to 10 of the square root of u du. Okay, which actually simplifies to 1/9 times u to the 3 halves divided by 3 halves from 1 to 10. And let me take this to the next page. So this is equivalent to 1/9 times a 2/3 times u to the 3 halves from 1 to 10. So we're looking at 2 over 27, and then you can just leave it as 10 to the 3 halves minus 1 technically to the 3 halves, which you can leave it as 2 over 27 times 10 to the 3 halves minus the values of 1. And let me evaluate this on the calculator so we can compare answers. So I'm getting that this is approximately 2.27. So 2.27 technically units. You can leave the one above it as an exact answer. So in this case, this will be units. And then simplify it as much as you can. The first box then in green would be our final answer, and this will be a decimal approximation. So they're messy in the evaluation, but this one turned out to be okay. I think that was because the derivative simplified. So we didn't end up with a messy constant that we had to carry along. That's actually it for example 2.